Mars could, without our knowledge, disturb the depths of our oceans. Located 225 million kilometers from Earth, it was once considered too distant to exert any influence on us. However, this certainty has recently wavered with the revelation of an unexpected butterfly effect. A modest gravitational attraction, initially harmless, would eventually generate immense whirlpools in the ocean depths. This hypothesis emerged when scientists examined the analysis of nearly 300 drillings conducted in the ocean floor during the 1960s. Their objective was to assess the strength of deep currents by examining the sediments, these deposits of sand or mud that have accumulated at the bottom of the seas over 65 million years. The ocean floor is composed of a superposition of sedimentary layers. When they follow a regular pattern, it indicates a gradual and uninterrupted accumulation of materials, a sign that the ocean currents have remained relatively stable. However, the researchers noted an anomaly. At certain specific times, no trace of sedimentation remained, which implied that an external factor had disrupted this natural process. The most plausible explanation lies in the existence of powerful underwater currents. Their intensity would have been such that they displaced the sediments from their original location. But the most intriguing aspect of this discovery lies elsewhere. All the interruptions noted occurred at a constant interval of 2.4 million years. In total, 27 periods of disruption have been identified, a phenomenon that cannot be attributed to mere chance. The researchers then understood that they were not dealing with simple irregularities in sediment deposition, but rather with a cyclical phenomenon. According to specialists, the only conceivable explanation originates from space, and it fits within the framework of major astronomical cycles. To grasp this mechanism, it is first necessary to mention the Milankovitch cycles. These cycles are named after the Serbian scientist who, a century ago, hypothesized that variations in Earth's orbital path and tilt could affect its long-term climate. The movements of our planet are not immutable and can be disturbed by various factors, notably by the gravitational influence of other celestial bodies. Under normal circumstances, Earth's orbit around the Sun resembles an almost perfect circle. However, at regular intervals this trajectory is affected by the gravitational pull exerted by Jupiter and Saturn, which then distort the orbit, giving it a more elliptical shape. Such modifications influence the amount and distribution of solar energy received by our planet, leading to climatic upheavals. According to Milankovich's theory, these variations follow cycles, well-defined cycles of 405,000, 100,000, 41 Suzin, and 23 Suzin years. It is assumed that these cycles are responsible for the alternation between glacial and interglacial periods. This hypothesis, initially theoretical, was validated in the 1970s when scientists discovered evidence of these cyclical rhythms by analyzing marine sediments. More recent analyses have revealed that beyond the Milankovitch cycles, other climatic changes followed significantly longer rhythms. Here, it is no longer a matter of tens of thousands of years, but of phenomena that span several million years. This is precisely what characterizes the great astronomical cycles mentioned earlier. Until now, our understanding of these phenomena was primarily based on mathematical and computer models. Finding geological evidence, attesting to the existence of these multimillennial astronomical cycles and their influence on Earth was a real challenge. But things have changed. Discoveries made at the bottom of the oceans might well provide the long-awaited proof. Indeed, the period of 2,400,000 years corresponds precisely to the traces of gravitational interaction between Earth and Mars. When these two planets follow their respective trajectories, their gravitational fields interact through a resonance phenomenon, exactly as is the case with Jupiter and Saturn. Periodically, the gravitational influence of Mars slightly disturbs Earth's orbit, bringing our planet closer to the Sun. This phenomenon, like the shorter Milankovitch cycles, has repercussions on the climate. It results in an increase in solar radiation received by the Earth, leading to a slight warming. However, scientists believe that this additional solar energy input remains moderate. It is not an upheaval such that our planet would become an unlivable furnace. Nevertheless, even a minimal climate variation can have notable consequences, particularly on ocean circulation. An increase in temperatures promotes the multiplication of large-scale storms, which generate whirlpools capable of carrying sediments down to the oceanic abysses. These phenomena, comparable to immense underwater vortices, play a key role in the dynamics of the seabed. The identification of these discontinuities in the sedimentary records of the deep sea represents a major advancement, undoubtedly the strongest confirmation to date of the existence of great astronomical cycles. As mentioned at the beginning of the video, this process is reminiscent of the butterfly effect. Every 2,400,000 years, the gravitational pull of Mars alters Earth's orbit, leading to climate warming. This warming stimulates the formation of powerful underwater vortices that eventually disrupt the dynamics of deep waters. The cycles highlighted in this study also coincide with certain periods of climate warming that are already well documented in Earth's history, notably the famous Paleocene-Eocene thermal maximum. This episode, which occurred about 56 million years ago, led to a temperature increase of approximately 8 degrees. Many hypotheses have been proposed to explain its origin, whether it be an orbital disturbance or the passage of a comet. However, this new study suggests that Mars could also have played a role in this phenomenon. Although these results are particularly interesting and convincing, there is still much to be done to establish a direct link between these astronomical cycles and the ocean currents. Deep. Certainly, the researchers have provided a plausible explanation for the gaps observed in marine sediments, but for now, it is only a hypothesis to be further explored. However, their success is crucial for the entire scientific community. Precisely understanding when these major astronomical cycles occur and their effects on Earth could prove to be decisive. This would notably allow for a better distinction between natural climate fluctuations and those caused by human activity. The study of these oceanic eddies also provides valuable information on the impact of climate change on the circulation of marine waters. This is precisely what makes this discovery particularly important, especially in connection with a major threat, the potential collapse of the Atlantic meridional overturning circulation. This system of ocean currents ensures the redistribution of water masses in the Atlantic, transporting warm waters northward and cold waters southward. It thus plays a key role in the thermal regulation of the planet and in providing essential nutrients for marine life. However, some researchers fear a slowdown, or even a halt of this mechanism, with potentially disastrous consequences. If this were to happen, the surface waters, rich in oxygen, would no longer mix with the deep waters, thus compromising the balance of the oceans. Yet, this possible link between Mars and Earth opens up a more optimistic perspective. It suggests that climate warming could lead to an intensification of deep ocean currents, thus preventing the seas from stagnating. That said, this hypothesis remains fragile. Evidence is still lacking. Some skeptical experts point out that, although the activity of eddies has indeed increased in recent decades, satellite observations show that their currents do not systematically reach the abyss, and do not always ensure effective water circulation. For now, it is impossible to decide. Only future research will determine who is right.